Okay, so here is the 2.1 algorithm section in a nutshell. So we're going to go through all these topics here. We won't be going through actually every single one because this section here is covered in, or some of this section here will be covered in the programming section where we do pseudocode and the other parts of the coding section are covered in the coding section of the website. So let's have a look at computational thinking. Okay, so we've got these things we need to understand. They're keywords, you've got to learn them. So abstraction. This is part of a thinking with algorithms where basically you remove anything that's not necessary. Okay, so the example I've got here is if we were writing a chess playing algorithm. So we're writing a machine like AlphaZero or something to try and play chess. When that machine is learning how to play, because it's AI, so it plays itself billions of times, there is no need to worry about things like displaying the chessboard or even giving the pieces images, because this is completely pointless. In essence, it could play it using just numbers where 1 represents a pawn, 0 represents a blank square, 2 a bishop, 3 a rook, whatever, and so on and so forth. So you don't need to worry about those things with this algorithm. And so that would be abstraction, removing any unnecessary information to help solve the problem. Okay, so decomposition is quite obvious, an easy one to understand. It's basically where you break down a problem into small tasks to make it easier to solve. So for example, with the chess program, you might have to have a part of the program that analyzes how good the current board is to give it a score. So the computer might say, oh, this board's better than this board, or this move's better than this move, various things. If you're writing computer games, you break it down into massive different sections between handling user input, sound, networking code, AI, even the graphics would be then broken down more and more and more into smaller and smaller parts. And the reason for this is it's just easier to solve when it's smaller. Okay, so then you've got an algorithm. What is an algorithm? Well, an algorithm is just a set of instructions that allow you to solve a problem, but it should be repeatable. So the algorithm should be able to repeat it over and over again. A basic example of that is a recipe in the real world where you get a recipe to make soup or whatever, and you can in theory repeat that over and over again to make soup over and over again. Algorithmic thinking or algorithmical thinking is essentially having a thought process where you're looking at how can I make this problem be solved with an algorithm. So looking at things like what steps would I need to do rather than just looking at the end result. How would you get to that end result? What's the path you would need to take? And last but not least is computational thinking, and that's just basically thinking about how could this problem be solved using a computer. So not very difficult. The main ones they're going to ask you in the exam is what is abstraction, what is decomposition, and what is an algorithm. Algorithmical thinking is just think about how to make an algorithm, so you should be able to work that out, which is common sense, and the same with computational thinking. Okay, here, so I'm going to go through 2.1.2 section with trace tables. And a trace table is a table that you create which shows all the current values stored in variables in a program. So what we essentially do is we're going to sort of run through the program ourselves one line at a time, and then we'll show what the variables store in them and any outputs that are going to happen. As always, best shown by example, so here we go. So let's say you get an exam question that says produce a trace table for the following code. So first of all, you look and you go, right, we've got 1, 2, 3 variables. We also have an output, so we've got 4 things we need to write about: number, I, total, and output. So first, draw a table, but obviously I'm going to insert a table, which is 4 columns high, and then I'm going to write in the names of the things. So number, I, total, and output. Okay, so that's done. And then what we're going to do, we're going to run through one loop, and then we're going to write the loop as we go. So first of all, number is 5, because number is 5. Then it goes for I equals 1, so I starts at 1. Then it says total is equal to number minus I. So total is equal to 5 minus 1. So we go 4. And then we output total times 2. So output 8. And then you repeat. So now I is going to be 2 because I increment, so we go 2. Number is still 5. You can keep writing 5 or you can just not write it. It doesn't really matter. If it doesn't change, you don't have to. I tend to always write it because it just helps me here. 5 minus 2 is 3. 3 times 2 is 6. And as you can see, there's a pattern that's going to emerge as I go through the code. So total equals number minus I. And we repeat. And obviously, at one point, you'll start to see there's a very clear pattern, which is quite common. But just check that, because there might be some crazy if statement that does something like, if it's less than 1, do something else. But obviously here it's not. So then we do that as 2. And then, of course, see this would be 5, 5, 0. And then double 0 is 0. So there you go. That would be the trace table completed. Okay. You might say to yourself, what's the point of a trace table? Well, it's quite handy to get the idea of conceptually running through a program and seeing what the outputs would be given different inputs. This can be very useful for finding errors, looking to make sure the algorithm is suitable and making sure it works. Right, so here we're going to go through flowcharts. Now, we're not going to cover them in great detail because we do cover them somewhere else, but a flowchart is simply a visual way of displaying an algorithm. Okay, so I'm going to go through them. Students normally find these okay, so I'm just going to go through a couple of examples. So the first example here, a common question is they'll ask you something like, what would be the output given these inputs? So here are the inputs and here's the outputs. They'll say, right, 3, 2, and then what would be the output? So let's do it. So basically you go from the start. So input num1. So the first number gets put into num1. The second time we get an input, we use the second thing they've put here. So num1 is 3, num2 is 2. And let's run the code. Is num1, 3, greater or equal to num2, 2? Yes. So then num1 is now equal to num1 plus num2. So num1 is equal to 3 plus 2. So num1 is 5. Output num1, 5. That'll be that answer. 1 mark for us. Hooray. Okay, input, let's do it again. Input num1, 5. So num1 is 5. If you need to write these down, I mean, you might want to. I don't, I just remember them. But, you know, you can do that when you do yours. So num1 equals 5. Num2 equals 8. Is 5 greater than or equal to 8? No. Num2, right, so number 2, is equal to number 2 minus number 1. Well, number 2 is 8, number 1 is 5. So num2 is now equal to 3. Output number 2, 3. Easy. Last but not least, 10 and 12. Input 10, input 12. Is 10 greater than 12 or equal to 12? No. So num2 equals num2 minus num1. 12 minus 10 is 2. Output number 2. We output 2. Bang. There we go. That's quite an easy one. Okay, so let's look at a different one with slightly more harder, with functions being used in the process. So they're using subprograms. In this case, they're actually functions because they return values. So let's look at this. So we run through it. So we've got our 2 inputs, and it doesn't always have to be 2. It just is in both my examples. So we go here, and this is executing a subprogram with no parameters called getInput. So we go over here, and we execute getInput. Now getInput takes, no parameters. So we run it. Input mark 1. So right, 16 goes into mark 1. 26 goes into mark 2. And then we return mark 1 and mark 2. Okay, there's no need to catch it here in algorithms and flowcharts. You just presume that mark 1 and mark 2 have gone back. So now I'm running a second subprogram, a second function, and it's a function, remember, because it returns a value. They both return values. So this one takes 2 parameters, mark 1 and mark 2. So we're sending in mark 1 and mark 2 that we got before. Remember, that's mark 1, that's mark 2. So right, we go over here. Total is equal to mark 1 plus mark 2. So then we've got a total of 42, because that's what they are added together. And then it says return total divided by 2. So we're going to return back here, total divided by 2, and then we're going to output the result. So we return total equals divided by 2, so it's going to return that, and that's going to be, obviously, 42 is 21, so the output will be 21. Okay? You might find they do something like result equals Okay, calculate, mark 1, 2. But you just have to use your common sense. Okay, if it's asking to output the result, it's going to ask you, what's returned from here, the next thing. But you have to use your common sense because there is no hard and fast rules with flowcharts. I prefer doing things like that. I also prefer doing other things like here. But there we go. I'm more of a coder, so that's how it is. So it depends on the exam. I think in the example here, they always just return back a variable they've used. They'd never say like, oh, output result. But you might have to just use your brains. I mean, they'll probably do something like result equals. They might do it like this. They might have it so they might have. In fact, that's probably what they would do in the exam. But obviously, there is no rule. So I'm trying to get you to use your brains because that's what you've got to do. I'm just going to line these up because I'm quite annoyed now. So, yeah, so they might do result equals total divided by 2, and then they might do return result, just to be more clear that you're returning result. But you just got to use your brains a bit there and obviously find out what they're asking. So let's do the next two really quickly. So we go here, we go over here, 35, mark 1 is 35, mark 2 is 32, we return that. We calculate the average, which obviously you now know is going to be, right, 35 plus 55 is 90, sorry. And then you return the result divided by 2. So there it goes back here and we output results. Obviously, that's quite easy because 90 divided by 2 is 45. And the same here, 18, 16, and then obviously we get an average of 17, as that will be 34. Okay, so that's how you do the flowcharts. They're not ridiculously difficult. You just got to understand what these little functions do and just use your brain and go through asking questions. And be very careful because they will try to trip you up. They will try to use things like if greater than 17 when the answer is 17. So they might have a question that says, is mark 1 greater than 18? And you go, or, whatever. And you might go, oh, it isn't or whatever. And it's the opposite. So just be very careful.